Okay, so separable differential equations. We've talked about differential equations. What is a differential equation? A differential equation is something with a derivative in it, right? And the goal in solving a differential equation is to find what? Kind of its antiderivative, the function whose derivative is equal to this, right? If it's even a function, okay? But now we're going to be dealing with more complicated differential equations where we have x and y intermixed. It's not just going to be dy dx on one side and x on the other, and then you take the antiderivative and it's easy enough, okay? So if I give you any differential equation, you have to make sure the x's and the y's are isolated, that they are not put together. So you've seen a slope field. What was an example of, give me an equation that you saw that was a slope field maybe. Dy dx was negative x over y, sure, that's a good one. So we cannot just integrate both sides because we have an x and y over here. What would the first step be that I told you to work with last time on this? You got to multiply by dx, so you end up with dy equals negative x over y dx, right? But I still can't do it because I've got the y over here. So what do I have to do then? Multiply both sides by y. What do you get? How about y dy equals negative x dx, right? And then we'll integrate from there. Actually, let's go ahead and do it. Notice what's the variable of integration here? Y. So what is the antiderivative of y dy? It's easy. It's the same as if it was x dx, because it's not saying it's not difficult. It's not saying integrate y dx. That would be a pain. Okay, what's this one? What's the antiderivative of negative x dx? Negative 1 over 2 x squared plus c, right? How is that any? The only difference between these two is I replace the x's with the y's and then put a negative out front. So what's the antiderivative of y? dy. 1/2 y squared. Well, we got to be careful here. If I put plus c over here, is this the same c as this c? No. So let's do this. Let's call it plus maybe d. But our goal ultimately is to do what? What's our goal? Get y by itself, right? So what would the first step be in isolating y? You're going to subtract d, right? So we got 1/2 y squared equals negative 1/2 x squared. What's that? Yeah, you could say plus c minus d, but remember, these are just both constants. Do we know the constant that they each represent? No. When I take a constant and subtract another constant, what do I get? A constant. So that's why we say we want a capital letter C for constant, because it can mean any constant. Okay? So we could say C minus D is just C. It's not the same C. It's capital C, which means any constant value, whatever it is. Okay? Then we don't have to worry about it so much. What would the next step be? Multiply by 2. So what do we end up with? Y squared equals negative x squared plus, well, you want to say 2c, right? But what's 2c? It's still a constant, right? Is it the same constant? No, but it doesn't matter. It's a constant, right? And then we'll isolate y by doing what? Square rooting. So y equals the square root of negative x squared plus c. And that's it. Yeah, that's it. Now, this is what kind of answer? What's the term for it? General solution, because it's got the plus c, but what would you need for the other one, the particular solution? You need an initial condition. So this tells us it's what kind of graph? It's a circle? Yeah? Is that right? Yeah, seems reasonable. Okay. Let's go ahead and take a look at another one here. Watch, it's the same problem. Nope. Okay, good. All right, what's the first step? We want to make sure that the x's are on one side and the y's are on the other. Okay, we're going to multiply both sides by dx. So we end up with dy equals 4 over x plus 7 squared dx. This one's pretty easy because there's no y values, right? It's just dy. Now what? Integrate. All right, you guys try this. You should know how to do this now. You don't need to use u-substitution. If you need to, go ahead. What's u if you're going to use u-substitution?
Negative u to the negative 2.
Huh? What is u? U is x plus 7. Du dx is 1. So du equals dx. And then we can substitute. So we have the integral of 4 over what? U squared du. Okay? And then we have the other side, but we'll evaluate this. How do I evaluate that? I saw some of you on your quiz. Natural log of u squared. Why do you know it's not natural log? It's the squared, right? So if it's squared, what do you have to do? Or anything? 4u to the negative 2. So what's the antiderivative of 4u to the negative 2? It's going to be u to the negative 1. Negative 4. Okay. And then plus c if you need. So then u, plug u back in, negative 4 times, well, yeah, times x plus 7 to the negative 1 plus c, or negative 4 over x plus 7. Okay, so that's the right side. What is the integral of dy? This is like putting a constant here, right? Of 1. What's the integral of 1? Or the antiderivative of 1? Y. Because we're taking in terms of y, right? So the derivative of y is just 1 if we're taking the derivative in respect to y. What's the derivative in respect? What is the derivative in respect to x of y? D dx of y. Y prime. Because y is a function in respect to x. What is d dy in respect to y? 1. Because this is saying that y is a what? Function, and x is the variable. This is saying y is a variable, and you're taking the derivative in terms of that variable. Okay? So, on the left, what do we end up with? Y. Oh, I guess I did do u substitution here. Okay. So we get y equals negative 4 over x plus 7 and then plus c. Notice how I did not put the plus 7 next to the y? Sorry, not the plus 7, the plus c next to the y? Why not? When you take the antiderivative of dy, you have to put the plus c there. Why didn't I put the plus c after this? Because when I go to subtract that c to the other side, I'll just get a constant anyways, right? Okay. Yeah, make it a capital C. When you use lowercase c, what you're saying is that there is a very specific value that c represents. If you use the capital letter C, you're saying any constant can be plugged in here. Okay, let's try this one. Okay, now I'm looking for the particular solution because I give you an initial condition. How about you guys try this? See what you can do. Separate the variables. Okay, how do we deal with this? Remember, the goal is to get x on all the x's on one side, all the y's on the other. What do we do? Okay, sure. Multiply both sides by dx. So you got dy equals xy squared dx. Now what? Okay. And I did see this, but it could be a common thing. If I divide both sides by y, that doesn't cancel out the y because what is it we're squaring here? The x and the y. So it might be better to distribute that or to square that side. So it's going to say dy equals what? X squared, y squared, dx, right? All right, now what? Divided by y squared. Now, I'm not going to write it as divided by y squared. I'm going to write it as multiplying by 1 over y squared. So this will be 1 over y squared dy equals x squared dx. You guys okay with this?
Yeah.
Okay. Now what's the next step?
Integrate.
Integrate both sides? How am I going to take the antiderivative 1 over y squared? He said natural log. Boo. Okay. We have to rewrite it as negative second, right? So what's the antiderivative of y to the negative second?
Negative 1/3 y to the no, negative y to the negative 1.
You guys okay with this? And again, take the derivative to make sure you didn't make a mistake. Power rule, negative times negative 1 is positive, y to the negative second, so we're good there. We do not have to put the plus c here. Where does the plus c have to go, though? Right, so what's the antiderivative of x squared? 1 over 3 x cubed plus c. Okay? Now there's a couple ways to go about solving these problems from here. It would be my recommendation to find out what c is right now. You can get y by itself and then solve for c, but it's going to be more algebra heavy. And we all know how you do with algebra. So, first thing I'm going to do is rewrite this just so it's easier. So it's negative 1 over y equals 1/3 x cubed plus c. What does it say our initial condition is?
1, 1.
1, 1. I'm going to rewrite that as just saying 1, comma 1. Right? So we're going to plug 1 into y, so we get negative 1 over 1 equals 1/3 times 1 cubed plus c. So negative 1 equals 1/3 plus c. And then subtract 1/3, so you get negative 4/3 equals c. You guys okay with this? Not too bad, yeah? Okay. Now what? Plug it back in. So we're going to plug it into this guy. So we're going to say this and this. Negative 1 over y equals 1/3 x cubed minus 4/3. But still, this is an interesting problem. We have to get y by itself, right? Okay, so since these have the same base, we could say negative 1 over y equals x cubed minus 4 over 3. That works, doesn't it? I'll look at it a different way in a minute. And then cross multiply, so we get negative 3 equals
Y times x squared minus 4.
I don't want to distribute because I'm trying to get y by itself, right? So we'll divide both sides by x cubed minus 4. So you end up with y equals negative 3 over x cubed minus 4. Where'd the plus c go? No, I did, but where did it, like, plus c was, the c was negative 4/3, right? I don't really see it in there directly, but it's because I combined and got a common denominator, right? Well, it's basically going to be the same thing. So I'm going to just multiply both sides by y. So I get negative, so it'd be negative 1 equals y times 1/3 x cubed minus 4/3. You okay with that? And then you're going to divide by all this. So it'd be negative 1 over 1/3 x cubed minus 4/3 equals y. And so that brings up the other point. This is important. This is the same as this, but it looks totally different, right? So again, when you get to one of those problems where you get this answer, but this is the one that it looks like, you got to do the algebra. Well, you don't have to do it a different way. You just have to be able to manipulate this. So how would you make this look like this? Okay, so you get what? This is where I'll put the fractions together here. Negative 1 over x cubed minus 4 over 3 equals y. And what's the donut? So the top goes with the bottom on top. Okay. And then the bottom goes with the top on the bottom. But it's the same thing, right? All right. Are we good with this? Okay. All right. I guess quick run through. What did I do here? I distributed the squared, so I got x squared, y squared divided by y squared. Then we take the integral of both sides, and again, it's not natural log. And then we're going to plug in our initial condition there. So that looks a little bit different, but it's the same answer. Plug in our initial condition, and then we're going to solve for y. So let's see here. What did I do? Got a common denominator, so I did method number 1. And then cross multiplied there, I guess. Okay. How would this be broken down on the AP exam? The AP exam, this is generally 5 points. You would get 1 point for separating the variables. So if you got down to this part without the integrals, you get 1 point. You would get maybe 1 point for taking the correct antiderivative here, and 1 point for the correct antiderivative there. So that's 3 total there. You get 1 point for just putting plus c. Yeah, make sure it's capital. If you do not put the plus c, they will not give you that point, even if you go to solve for c later. So that's 4 points. And then you're going to get the 5th point, basically, for the rest. Because the rest is just algebra, isn't it? Right? Okay. Okay, try that. So I guess I don't need to write this up here. We can just go over it. First thing we want to do is rewrite it using some sort of algebra. All right. I multiplied both sides by dx because that's just a good idea. But how could I rewrite e to the x minus y? How do you separate it? It's not going to be e to the x minus e to the y. No. Okay. Some of you guys had it. Look, if I said 3 to the x plus y, that is not equal to 3 to the x plus 3 to the y. That's equivalent to saying 3 to the 4th plus 3 to the 3rd is 3 to the 7th. Is that true? No. How do you get 3 to the 7th? 3 to the 4th times 3 to the 3rd is 3 to the 7th. Right? So what did you say? E to the x times e to the y? Or e to the negative y? But because it's a negative y, I just moved it down. It doesn't matter. Let me rewrite it here so you can see it. dy equals e to the x times e to the negative y dy. Sorry, dx. You guys okay with that? Okay. Now, what do? Multiply by e to the y. So you got e to the y dy equals e to the x dx. Now what? Now we're going to take the integral. What is the antiderivative of e to the y dy? E to the y. What's the antiderivative of e to the x? E to the x plus c. Now, it's asking for the general solution, so we don't have an initial condition, but what do we have to make sure we do? We got the plus c. You got to get y by itself. How are you going to do that? Natural log. So solving for y, we could take the natural log of both sides. We end up with that. Huh? Okay. So e to the y equals e to the x plus c. If I take the natural log of both sides, right? What does this become? I bring the y out front, right? So y natural log of e equals all of this. So what's natural log of e? So y equals the natural log of e to the x plus c. Yes. No, why is it sometimes it's an absolute value? Well, when you have, let's say we're taking the integral of 1 over x dx. The antiderivative of 1 over x is the natural log of the absolute value of x, right? We didn't take the antiderivative of a rational function. We took the antiderivative of an exponential function. And when I took the natural log here, what is this value always going to be? E to the anything is positive, I guess, unless c is a negative value. But yeah, you only put the absolute value when you're taking the antiderivative of that. Again, we're going to get there eventually. Hopefully. All right. 2 more problems. Let's see what we can do. What is the particular solution? Oh, 3? Okay, 3 more problems. 2 more slides. All right, go for it. All right, let's take a look at the first one. Okay. Number 1, what's the first step? In general, the first step is to separate the variables, right? So we should have gotten 1 over y squared dy equals x dx. Then we're going to integrate. We do not get the natural log of y squared. We get that. And then what's the next step? Nope. Next step. Solve for c. So you're going to plug in your initial condition. Solve for c. c was 1/2. Plug that in. Now we're going to get y by itself. How are we going to do that? Somebody?
Oh, what? The answer?
How are we going to solve for y?
Multiply both sides by 1.
Okay. Put it over. Oh, I multiplied by -1 there. Okay. And then cross multiply. So you got y equals, I guess you could just take the reciprocal. Right? If you got y to the -1, that's the same as saying 1 over y, right? So negative x squared minus 1 over 2. You could cross multiply and then divide, but how do I get this to say y? Take the reciprocal. So we'll take the reciprocal this side. 2 over negative x squared minus 1. Now why does mine look different than this? Yeah. I just multiplied a -1 over a -1, I guess you could say. -2 over x squared plus 1. All right, you guys okay with this? And then number 2, kind of a pain, huh? What's the first step? In general, what's the first step? No, that's part of the first step. What is it called? Separate the variables. I'm pushing that term because on the AP exam, if you can't separate the variables, even if you integrate something right somewhere along the way, you do anything right, if you do not separate the variables on the first step, you get a 0 on that whole problem. Okay? This is the one where it's like you don't do the first step right, it's 0 across the board. They don't look for partial credit. So we have to separate the variables. Now, dy equals 2y minus 1 dx. You guys okay with this? Notice I put that in parentheses, right? You cannot subtract 2y from both sides and call it good because you've got times dx here, right? So that won't work. And so somebody else might want to distribute. dy equals 2y dx minus dx. Am I right there? Yeah, in a way, right? But how would I get the y over there? Okay, but if I divide everything by 2y, those cancel out, but now I got a 2y underneath this one. So that doesn't help. Okay? I saw this earlier. Subtract 2y. Now, obviously, algebraically, that doesn't work because we have the dx outside the parentheses, right? But here's the other reason. It's like saying this, 2y plus dy equals, even if this was true, it's not algebraically, but let's say it was. How do we always see an integral? It's always the integral of something, what? Times dy. It has to be that. It cannot be the integral of something plus dy. It's impossible to do it that way. Does that make sense? So when you separate, make sure it's this times something. So what would I do to get that times something? Divided by 2y minus 1, right? So we end up with 1 over 2y minus 1 dy equals dx. Now what? Now I'll take the integral. Ooh, I know. This side's x plus c. Yeah. You do the left. Is it natural log? Yes, it is. Why? Because the variable's on the bottom, and what's the exponent? It's a 1, right? So it's a natural log. It's a u-substitution if you can't see it any other way. Since you're multiplying by 2 down here, what's your antiderivative going to have in it? It's going to have a half, because you have to get rid of it. 1/2 natural log of 2y minus 1. Again, take the derivative and make sure you're good. The derivative of this would be what? 1 over 2 times 1 over 2y minus 1 times 2. So the 1/2 and the 2 reduce, you're left with 1 over 2y minus 1. You guys okay with this? Okay. Now what? What's the next step? Plug in the initial condition. So you get 1/2 of the natural log of 2 times 1 minus 1 equals 3 plus c. So 1/2 natural log of 1 equals 3 plus c. Okay, I want to make a point here. One of the reasons the absolute value is there is if this value was a negative, then you couldn't take the natural log of it, right? So we put the absolute value there so that it becomes positive so we can take the natural log. The way that's related is on slope fields. This is a natural log function. I don't even know if this is right, but let's say, what's natural log look like? Something like this, is that right? Well, we might get another one that looks like this, the reflection of it. And we have a what? We have a vertical asymptote in either case, right? The initial condition tells us if it's on this side of the asymptote or on this side of the asymptote. Right? And the natural log, if I take the natural log of a negative, then you're going to have the negative version of it. Again, we'll explore that more later. Okay. All right, what's natural log of 1? 0. So this is all 0. So C equals... All right, so you got 4 out of 5 points. Now let's go back and do math. Do algebra. So 1/2 of the natural log of 2y minus 1 equals x minus 3. How are we going to solve for y? Multiply by 2. So we got natural log of the absolute value of 2y minus 1 equals 2x minus 6. Make sure you distribute it. Rewrite it in exponential form. E to the 2x minus 6 equals 2y minus 1. That's the value. How do I solve that? Do you guys remember how to solve absolute value functions? All right, if I say the absolute value of x equals 5, what is x? X is 5 or x is negative 5. So you take whatever's inside and you set it equal to the positive version or the negative version. So let me rewrite this as the absolute value of 2y minus 1 equals e to the 2x minus 6, just to flip that over. If I'm going to break it into two cases, 2y minus 1 equals e to the 2x minus 6, or 2y minus 1 equals negative e to the 2x plus 6, because I have to distribute the negative, right? Okay. Solving for each one of these, 2y equals e to the 2x minus 5.
The 6 is part of the exponent.
Oh, it was, huh?
Yeah.
Whoops. Sorry. 6 was part of the exponent. So minus 6. Okay. Thank you. So 2y equals e to the 2x minus 6 plus 1. And so y equals plus 1 all over 2. And then this one is 2y equals negative e to the 2x minus 6 plus 1. Yes. But there still is only one answer here. How do you know which one it is? If I plug in the initial condition, 3, 1, does it work? If I plug in 3 here, what do I get? 6 minus 6 is 0. E to the 0 is 1. Plus 1 is 2 divided by 2 is and I was supposed to get 1. If I plug in 3 here, what do I get? 0. That'd be negative 1 plus 1 over 2, which is 0, right? Okay, so that absolute value right there is very critical because it tells you which side of the graph or which above the graph or below the graph are we talking about. So it's this one. So here's a side note. When you have something like this and you see it often, you break it down like this. Is this work related to the problem?
Yeah.
In a way, but did it lead us to the solution?
No.
So once you do all this, you cross that one out.